thank you, of course, everybody for joining our office hours today. As you can see, I'm joined here today by some of the engineers from the Arbitrum team, as well as some of the engineers from the Graph. So before we actually do get into stuff today, can we actually maybe go around and give some intros? I guess for me personally, I'm Hunter, the community manager over here at Arbitrum, and the moderator for today's call. Fred, if you want, you can kind of go first, and you can go from team to team.
Sounds good. Hey everyone, I'm Fred. I'm part of the application engineering team at Off-Chain Labs, the team building out Arbitrum. We work a lot on the protocol side of things and the token bridge and just consuming Arbitrum as an application as well. So deploying smart contracts and composing all that. So for example, if you ever use bridge.arbitrum.io, you're probably using a lot of the stuff that we maintain and work on and iterate on for features and helping other people in the community integrate with and just leverage. So next up, maybe Daniel G.
Yo, I'm Daniel. What Fred said, basically. I work with Fred on the application engineering team, currently focused on technical research and content and things like that. Harry.
Hi, I'm Harry here. I'm also in the application engineering team, and I usually help people to integrate with Arbitrum.
Does anyone want to, I guess, intro Chris for him, or do we know enough about Chris to intro him?
He's been doxxed. So yeah, Chris has been doing L2 research for a long time now. He joined us some time ago and does some awesome work there, both on the research side of things and also on our SDK that helps people integrate with the protocol.
Shout out to Chris. And if you guys are on the graph, maybe Pranav,
okay,
you can kind of Ariel,
I can go next. Can you hear me? Yeah. Well, here, Ariel, core contributor to the Graph protocol. I'm working at Node and leading the smart contracts team. Pablo?
Hey, I'm Pablo, and I work in Ariel's team, so on the smart contracts for the Graph at Node, and pretty focused on the L2 and Arbitrum stuff lately. I guess. Pranav?
Not sure if Simon or Pranav want to present yourself.
Hi, I'm Simon. I'm a solutions engineer at Node, focusing mainly on decentralized network migration and dApps integrating with the Graph in general.
Hello. Hey guys, I'm Pranav. I'm also a solutions engineer at Node, one of the core devs at the Graph, and I've been focusing on the network migration, indexer participation, and also for a brief while I also looked at chain integration on the hosted service. So yeah, that's been my part.
All right, awesome. Yeah, thank you, obviously, all you guys for the intros. So the general flow of today's conversations mainly just going to be about, obviously, like what both teams are going to be kind of working on, bridging, as well as moving over to Nitro near the end. If you do have any questions that you want to ask the Arbitrum team or the Graph, please either leave them in the comments of the tweet that I'm about to pin, or you can just wait till the end when we do start calling some people up. So we have a lot of time because we do have a bunch of questions here, and I'm sure these guys can go on forever talking about protocol related stuff. So I would say let's start off with just briefly kind of what each team is currently working on, and then we can maybe go from there. So if you want, maybe from our side on the Arbitrum side, Fred, Daniel G, Harry, whichever one of you guys wants to start. What have we been working on as of late?
I can.
I can.
General.
I can start with an intro about what's we currently have running on mainnet and why we are doing all of this and why we are basically building on Arbitrum. Basically, the Graph is a decentralized protocol to organize the world's information, right? And we have in the network, there are a number of different stakeholders and players. One very important ones are indexers, and there are around 170 indexers. that needs to perform a number of operations on chain. So they advertise that they are indexing a subgraph. They need to do like a number of different actions like staking, allocating, and closing allocations, claiming the fees, etc. And there are other different stakeholders like curators that perform different actions, like choosing the subgraph that will be popular and trying to direct the attention of indexers, and delegators that provide security to the network by sort of, let's say, lending capital to indexers. So all these actions are today running, the protocol is running on mainnet, and all these different stakeholders or players in the network needs to perform on-chain actions. And as you might know, like Ethereum was getting more and more expensive. It's getting popular. More projects are using Ethereum as the L1, and the same thing was happening to the operation of the graph on mainnet, right? It was getting more expensive for all these different stakeholders, particularly indexers that need to perform frequent actions. They are getting their, the cost of just like sending transactions up and up, and the considering that Ethereum is getting more and more popular, and it's getting even more popular with L2s and more people building different applications on the L1. We needed to find a way to scale that, right? Currently, the network has 170 indexers and around 400 subgraphs, but there's an ongoing migration from the hosted service, and the hosted service has some really thousands of subgraphs. So we needed to find a way to really scale and to really be future proof and to have many years of scaling by moving many of these actions that are happening on the L1 on somewhere else, right? So by like thinking about different designs, we were like, okay, what things we can do, right? Like we can create an app chain, we can maybe evaluate one of these L2 solutions. Maybe I don't know, like there's also CK rollups. There are like a number of different things. But when we started the evaluation, like we saw that Arbitrum was a bit ahead of the rest, and it was like also EVM compatible. So we wanted to have something that didn't require rewriting all the contracts. So that's why we started like thinking about how our network might look like running on an L2, right? With all the challenges of that. Like it's easy to say, but there are many challenges in doing that. And we can discuss about the challenges, but I don't want to maybe use all the time myself. So if you maybe you can start with some questions about that.
For sure. Maybe it's worth unpacking a bit everything that goes into this migration, right? Because I think there are many independent parts. For example, one of the things you've worked on as part for this migration that I'm aware of is bridging the graph token itself, right? Because a lot of the protocol is intermediated by the graph for like curators and for people to paying for queries and all that. And you wanted to have a strong notion of what it means to have this token on the L2, right? Do you want to maybe talk a bit about how you think about that?
Yeah, one of the core. I mean, we had to decide on many things related to how we are running the protocol and the L2, right? Because we have I mean, depending on your application, you can deploy your protocol on an L2 independently, because like an L2 looks like a different chain in a way. And in some cases, a protocol can be isolated, right? Like you can think about a DeFi project, like I don't know, anyone Uniswap. You could bootstrap the Uniswap on an L2, and the main challenge there is to get the liquidity into the Uniswap, let's say L2, whatever flavor of L2. But in our case, we have a running protocol that coordinates multiple actors, and like moving things to L2 sort of create some challenges because we now have a split network, right? Some people, maybe some indexers are running on the L2, some of them are running on L1, some delegators on L2. Like, do we create a global view of everything? Do we have it partitioned? So that was one of the main things, right? And so what we wanted to have is some sort of, we need to clearly move some state from L1 to L2, but we wanted to have some control in that process. So we look into the standard bridge that you can move around like tokens. But in our case, we not only wanted to move tokens, but we also wanted to move the some state, right? Initially, it's maybe moving GRT across the bridge, but after that, what we want to do is to help people make them move their delegation easily through the bridge to the L2, right? So we wanted to have a bridge that we can adapt to our needs to make it easier for users to perform some of these actions. Okay.
For sure. And an interesting thing for that, in my opinion, which is something we think a lot about as well and discuss, is that there is a difference between an application being multi-chain and an application being cross-chain, right? And one of the things that we've done a lot of work on recently on the Arbitrum side of things is trying to facilitate these cross-chain kind of applications, right? That is, when a protocol actually understands and encompasses both the L1, L2 different execution environments and how all that composes and goes together. And we've been working on adding like more affordances to make this composability more seamless. And it was really cool to see all the work you guys were doing on actually leveraging these things and also thinking about this.
Yeah, Pablo can add more detail about this, but one of the things we know that it's challenging to have a protocol running in two places. The goal would be to really have everything migrated to TL2 because it's going to make many things simpler. But we know that it's not going to be easy to do it in one go because we have a running network, right? Like it's not that you can turn off the network, tell everyone to wait, and we do like I would say a painful migration process because it needs to be user initiated, right? Like people need to move their stake, they need to send transactions. So we so one of the things is like, okay, we have a running network, we need to keep it running, we need to deploy to L2, but everything needs to be working, and we won't stop the network. So that's one of the things. The other thing is we can have many kind of L1 to L2 interactions and also L2 to L1 interactions, but we want to sort of minimize that in the sense of like, we thought it was more secure to keep each network running or L1 and L2 deployments running as standalone as they can and try to minimize any surface of like moving or requiring moving state over, okay? So in our case, we sort of minimize that by keeping only the rewards distribution, like moving some GRT over from L1 to L2 to be the only, let's say, surface of interaction. And also the migration process, that we sort of think about the migration to be a one-time action. Like if you're an indexer, you migrate once, and it's not something that's going to be supported like a standard thing that you will be doing like frequently, right? So that was sort of the design philosophy like we had in mind, like let's try to reduce interaction to minimize issues, potential issues. Pablo, maybe you want to add something about that.
Yeah, I think you captured it quite well. And in the end, like the design we ended up with, other than moving GRT to L2 and then back to L1, everything else where we send state across layers, it's only from L1 to L2. We have nothing that, for now at least, nothing that requires sending state from L2 to L1 because there is that inevitable 7-day delay. So we wanted to avoid that as much as possible. And I think luckily we ended up with a design that has none of that, at least for now.
For sure. I think there are two interesting things here, directions that I think are really cool. One of them, I'm going to say for later, if Chris is able to join the speakers, which is cool patterns that you can do when you kind of like flip instead of L2 to L1. You can do a lot of things where you kind of just inverts the flow of messaging to avoid that. But that starts getting very like complicated. We can talk about it later. But something else which is really cool is when you do need to do these migration flows, something that we've thought about like quite a lot, and we've actually chatted quite a bit about it with you as well, Pablo, is how to minimize the complexity and the number of transactions and engagements for a user going through this flow, right? One thing that comes to mind is, for example, the deposit and call. That is, as you're sending your assets from L1 to L2 or something like that, what if you can compose actually functionality with that, right? And just have everything run on a single transaction to just minimize the friction from a user perspective as much as possible.
Yeah, and that is, I mean, when we started out writing the bridge, that deposit and call functionality wasn't quite there. I don't know if you guys had finished that already. I know it was a work in progress. So in the end, what we did is in our custom bridge, we ended up adding a similar like deposit and call functionality, but using a whitelist. So only the contracts from the protocol that need to send state can do it. But I'm sure once we can incorporate that more arbitrary deposit and call function, then it's also going to be useful for users in case they want to send GRT and do something else from one side to the other. But yeah, for now we kind of have a re-implementation of your deposit and call, but since in our case it's whitelisted, it means there's a lot of the griefing vectors that you have in the generic case, the permissionless case, that we luckily I think don't have to deal with. So we can do it a bit simpler, like with a bit less care for those edge cases that you have to handle.
Yeah, no, exactly, and that's why we held off on putting it live. Is as you say, there's these griefing vectors where I guess just for a little more context here for deposit and call, it's kind of this after you do a deposit, it's this arbitrary callback function. So you can include data that can make any call, that can call any other contract after the deposit. And yeah, in your case, you have a whitelist, so we can pretty clearly reason about what that thing is. It's not truly arbitrary. If it is arbitrary, it felt like for us it was a little too much of a foot gun for developers, since now you can make some sort of call that ends up failing, that ends up reverting, say because it doesn't have enough gas, and how exactly to handle that became very hard for us to reason about. So we just thought we're going to hold off. But yeah, at the application level, obviously at the level of a custom bridge or at the level of an L2 application, anybody can sort of create similar behavior in a constrained way. So yeah, cool to see you guys doing that.
Yeah, I can see how it's a tough challenge for you guys to solve. Like, how do you do the generic deposit and call without opening up a bunch of security issues?
It gets very weird, and we had like a short list of possible solutions, and all of them were weird. For example, we started toying with the idea that in the case of this particular failure, you send a cross-chain message back down to L1. That'll effectively, so you have to sort of plan on that. That undoes whatever action you did on L1. So if it's a token deposit now, a week later, you can at least get them back. But yeah, you can see this just gets ugly and weird. So yeah, a whitelisted version is totally happy and good.
Even with the whitelist, we did have some challenges in terms of like the whole calculating gas when you're sending the retrieval tickets and things like that. If you have a whitelist of contracts and the function that you can call, but anyone can call that function, that's already a challenge in that. Like, how do you ensure they provide the right gas? And we had a few conversations about this with Fred, and ended up coming up with something that I think will work and kind of solves that challenge, but it definitely wasn't an easy thing to reason about.
Yeah, and in general, just paying for gas for these retriable tickets. When we say retriable tickets, we're talking about cross-chain messages from Ethereum to Arbitrum. And essentially there's a few different ways of using them, but often what you're doing is you're kind of publishing this L1 message that funds the execution of the L2 message. So you're kind of depositing Ether and then using that. And there's a number of different dimensions of things you have to pay for there to get your transaction executed. And yeah, figuring out what exactly to estimate and when and why and how is sort of it's just sort of a new opens up this new space that at least, if you're an Ethereum developer, you probably haven't seen before. So yeah, fun stuff.
Now that you bring that up, there is actually something else which I think is really cool that you all were exploring. And I think that was the use of relayers, right, on cross-chain messages. Could you maybe talk about that a bit?
Right, yes. So in our case, what we have is there is this, we're proposing introducing this drip function that certain people can call. At first, we thought maybe anyone can call it. In the end, we're kind of restricting that a little bit for now, I think. But basically, there's a certain amount of people that can call this function, and this function will generate a retrievable ticket that sends tokens and some data to L2. And then that ticket has to be redeemed on the L2 side, hopefully pretty quickly, so that the state is synchronized as much as possible. And on the other side, we receive, oh, these are the new rewards that I have to distribute, and these are the values for the variables that I need so that I distribute the right amount. But we came up with the problem of, okay, but then what if the gas for that initial retrievable ticket is not enough, and then the ticket is sitting there, and then no one really wants to pay the gas to redeem that? And then what do? The protocol will sit there until someone kind of pays the cost for everyone else of funding that. So that's where we're starting to think about, we've been thinking for a while about introducing a keeper reward for calling this drip function, so that whoever spends the gas on L1 can receive a reward in GRT on L2. So there are two things there where you only get the reward for that call once the ticket is redeemed in L2. So if you leave it hanging there, you won't get any reward. But also, even if you want to grief everyone and just like call it on L1, pay that cost, and then never redeem it, we are also thinking about providing a reward for whoever redeems the ticket on L2, so that they can also get part of that reward in GRT. And then if the griefer sends the ticket and forgets about it, then there's still an incentive for people to call that L2 side of things and finally redeem it and close the loop, so to speak. So yeah, and we thought about using like relay services. I know there's a few, but in the end, it kind of fit well, I think. And this is all still in a proposal stage, but I think it kind of fits well with the indexer role that we already have. So indexers have an incentive already for calling this function. So we're thinking about making the indexer agents themselves be the ones that call this both on the L1 side and the L2 side. So it's still kind of a relay execution market, but kind of restricted to other actors that are already participating in the protocol. I don't know if this answers your question.
No, that's very cool. And yeah, we definitely like this idea. It's one of these like vaguely theoretical things we've discussed a number of times, but yeah, it's awesome to see you guys going forward and implementing it. Just to be, in case anyone's lost, just for a bit of context here, this basically just has to do with, there's this fundamental limitation, I guess you could say, or this thing you have to work around when you're sending cross-chain messages, which is essentially, you're initiating a message from layer 1, it's going to get executed on layer 2. You can't guarantee the success of execution at layer 2, because that just wouldn't be economically viable, right? There needs to, if nothing else, there needs to be sufficient gas. But we don't want to just let it fail, especially in that case of you didn't supply enough gas, because now you've just, done a cross-chain message and the L2 side failed, and that could be very bad. Like you could just lose tokens in a token bridge, for example. So we want to preserve atomicity. So what we say is, okay, we try to execute it initially. If you didn't supply enough gas, you can retry it. That's why we call it a retriable ticket for the next week. But the problem he was just discussing was, okay, who's going to actually pay for that retry? And what we sort of do, like in our bridge user interface, is we try to just surface the fact that it failed in this way and say, hey, please, it's time for you to redeem this. Go ahead and redeem it. But yeah, I mean, ideally, more and more tooling, more block explorers, more interfaces would make this more and more visible. But one of the the cooler space of solutions is what you're describing there, where there's just an incentive layer for parties to redeem these tickets. So yeah, that's very cool.
100%. I find
in the case of, yeah, sorry, Pablo.
No, just a comment that, by the way, it was pretty cool that I asked you guys about, and maybe a week or two later you came up with, oh, hey, here's the interface you can query to see who the redeemer was. And yeah, that was great.
For sure. I find the design space around these things just fascinating. Just like, for example, when we're talking about the retriables and actually like starting functionality in one domain, like one chain, the L1, and finishing it in Arbitrum, the L2, just there's so many things that go under the hood there, right? Because you're paying for execution in one side and state transition, but you're also like going across to a different fee markets. And one fee market can't necessarily guarantee you're going to get access to the other one because congestion, like you can have the L2 congested while the L1 doesn't have a lot of congestion, or the other way around. And to build a system that is consistent with all this and it actually still provides a good developer experience is an interesting challenge. And how just like relayers and keepers fit into all this is something that I find pretty cool.
Yeah,
And
the
to
challenge
comment,
is kind of,
yeah,
sorry,
go on. I was going to comment on something else. Go on.
I was gonna just to sort of like I think the core of the challenge is, as you said, there's these two independent environments with their own fee markets, and these environments are asynchronous with each other. That's kind of the thing you have to design around. Is within those constraints, you want to get something like atomicity between the two sides, and that's where retriable tickets come from.
Exactly. And to build on what you said, yeah, it's about the environments being async, right? And in some cases, you just can't get away from trying to synchronize the state in two different places and be sure it's following along in a synchronized way. But many times you can also like design your system around that, trying to think of it more with like perspective of like eventual consistency, which is kind of like what our token bridge does. That is, it never expects the two sides to be fully synchronized in terms of states and certain ordering of stuff. But it's kind of like everything eventually is always consistent once stuff that initiated on the L1 settles on the L2. Because it's just different free markets, right? So it's really hard to guarantee will be executed in the same ordering because of congestion and stuff like that. I think it's very early days around this stuff as well. We've seen a couple of cross-chain applications, and the design space is very much still like unexplored for different things.
Yeah, on the application level, yeah.
Most of the
Yeah.
most of the applications I've seen are deployed as I mentioned before, standalone. Like you have standalone deployments on L1 and L2, and it's like a different product on a different chain. And I think that maybe the ones that made more progress were like DeFi projects, right? That they have the people in the community had the I don't know, they wanted to use they wanted to do swaps like cheaper, and asked for these projects to be deployed on L2s. So we have a number of them, but they don't do a lot of cross-chain communication, apart from maybe breaching the token, right? Like you breach tokens. Once they are there, you just deposit them on the new platform. The one that did like some progress on that was Maker. I think they were exploring how to have native minting on different chains, because they basically, well, they accept deposits on ETH and other collaterals, and they mint DAI. So they were looking into different design architectures, so they were able to not just mint on the L1, but mint on the multiple L2s they want to be, or different chains. So there's a lot of research and investigation from the Maker team on that. But and we also saw the experience from Lightyear, right? They migrated the protocol from L1 to L2, and they have some, I would say, similar challenges to the graph. So that's also like inspire some design architectures that we can use, but at the same time we are like really exploring the best practices together, right? Like we decided to have a bridge that we can where that is possible, that we can upgrade in case we need to add some feature or something changes. But I mean, we will be best practices for other people in a way, like the good and the bad, right? Like the bad things we did and the good things probably other people can use. So
For sure, 100%. It's very early days in terms of like just understanding the design space and the different things that work and don't work. And yeah, these are a couple of the teams that are truly on the forefront. Yeah, you guys at the Graph, Maker, Aave, Live Peers, doing some really cool stuff. I find it particularly interesting the debt ceiling scheme they have, right? And understanding that different places you're minting at have different security characteristics, different things going on, but the protocol can still take that into account and keep a consistent like flow of things. Something else that I think is really cool as well that I think these teams tackled, I'm not sure what you guys have been thinking about, is cross-chain governance, right? There are a couple of different ways that this can go about, but it's something that as well people don't have like strong standards or let's say like go-tos where they actually like, for example, the classic thing is you just have a spell, just do your delegate call, easy to reason about. But what happens when you actually need to dispatch various spells with different things going on various different chains? It's things that we don't have the tooling for, we don't have best practices, and we're just setting the standards right now as we go, right?
Yeah, that was another thing that we had to decide for the network. And initially, we basically decided on doing like a new deployment, like a governance deployment on the L2. And what I mean with that is like there's a number of, I mean, the graph is managed by a council. It's not like token based voting. So that made it easier in the sense of like the same multisig can be deployed on L2 and the same owners can control the multisigs. But it's in the case that you have deployment of multiple networks and you have common parameters that like I would say regulate how the networks or the apps run. It's a good. I think it's a good thing to have like a way to sort of like send actions at a distance from the L1 to N L2s, particularly if you have a multi-chain deployment. But in our case, it was different. Maybe in the future we'll need to have some sort of like sending over state from L1 to L2 for governance purposes. But we sort of we don't have that. Well, I mean, that challenge is not that important in our case than like the issue of partitioning the network. The idea is to after after a few months of operations in the L2 and gaining confidence, the idea is that we can get most of the protocol migrated to the L2, and 100% of the protocol migrated to L2 because that's the way it will work effectively. Like having a partition network is not something that is going to be, it's going to be hard for anyone running the off-chain components that are needed to run the network, right? Like the indexers needing to know where to send the transactions, like consumers needing to know where to like send the queries, etc. Yeah.
Yeah, and I think for that makes sense. And I think we've seen for other use cases, there's situations where depending on sort of what affordances this governance has, or like what the expectation is that it will actually do. If it's a sort of situation where you have some governance that does some sort of updates, but very rarely, it's expected to happen very rarely, and they don't necessarily need to finalize quickly. Like these aren't user-initiated actions; these are just upgrades to the system that happen once in a while. It can sort of be nice to just say the governance lives in one place. So if it already exists on the L1, it just sort of stays on the L1, and you just add this affordance to send a cross-chain message to layer 2, which does whatever upgradability on layer 2 also, or even in reverse, right? So yeah, we've seen this is another place where the sort of directly using the cross-chain message system has come up a lot, is just sort of like sharing the result of a vote.
Yeah, and in some cases there might be some applications that require synchronization, and you need to update some state on L1 and L2. But again, like as we don't have like as we are learning about like how atomic these transactions transactions can be. I think that it's best to not rely on that synchronization and like see the bridge as a sort of a wormhole. You're sending something. It's not easy to get a signal back, and so not try to rely on synchronization, and try to, well, I mean, learn as much as we can from this process and maybe improve it. You as one of these L2 teams, try to maybe even designing new ways of like making things easier for developers. But today I will try to think as much as we can to have to not rely on that. I think it makes things easier and more robust, and it's one of the design patterns. But I think, yeah, in the future there will be more cross chain communications. There are some teams working on also improving that and making it faster, like Connext. And Nomad. So this is something that I will keep evolving. And as L2s also become more standardized and add some mechanisms, developers will gain confidence in using those.
Yep.
Awesome. Yeah, I think at this point we can probably maybe start shifting the call a little bit to talk a little bit about Nitro. It's, this is an update that we've been talking about on our end for quite some time. So maybe engineers on our side, maybe if you want to give a brief introduction to what Nitro is bringing to Arbitrum 1, and we can kind of go off some questions that the graph had for us there.
I can start. Feel free to step in, whoever and whenever. But basically, yeah, so Nitro is going to be this system-wide upgrade to Arbitrum. And essentially, in its current state, in terms of what's live on mainnet now, Arbitrum is a layer 2, obviously. It's an optimistic rollup that kind of has the ability to emulate Ethereum, to emulate the EVM. So as a smart contract developer, you can deploy smart contracts on it as you would on Ethereum. With the Nitro upgrade, it won't just emulate the EVM, it'll essentially be the EVM, which is to say that it'll use a fork of the Ethereum software directly. And this is what this translates to is better, but closer compatibility with Ethereum itself, which makes developers' lives nicer and easier, and also lower fees, which is good for everybody. So that's the upgrade. So the team has really been focused on that. And then I think that's the core of what we mean when we talk about Nitro. There's a number of sort of peripheral things around it where we sort of said, okay, well, as long as we're upgrading the system, let's we can make various quality of life improvements that are also important. Some of which have to do with cross-chain messaging. We can talk a bit about that. Yeah, so that's kind of what we've been focused on. We have a Nitro testnet up that's running. It's a layer 2 running on top of the Go Early testnet. Go Early, however you say that thing. It's running there. Yeah, the next step we're basically going to, so the mainnet chain will eventually become a Nitro chain, right? So we'll keep the same state, but we'll upgrade it to use the Nitro stack. That's kind of the plan. Anything else you want to add there? That's a very high level overview, but I think that's what Nitro is.
No, it's a good overview, and maybe I have a few questions. Like, do you? So the idea is that Nitro is something that you can be upgraded in the sense of like everything will look the same for developers running on the current deployment, and like once the Nitro is upgraded, everything will be transparent, right? Or most of the things, I guess.
Everything will certainly be transparent, and in terms of most applications, you shouldn't have to, most applications running on Arbitrum shouldn't have to actively do anything. They'll just continue to run, once this upgrade from what we call the classic stack to Nitro happens. We have a document, sort of a living document, where we name some of the changes and potentially breaking changes to look for. So that is something you should keep an eye on. We've also in terms of like client side stuff and tooling, and this is something Chris and Harry and Fred have worked a lot on. We sort of have our Arbitrum SDK package. We have like a migration version of it, where basically if you're using our SDK, you can just use the migration version, and then you won't have to like actively you won't have to do any active update over the course of the Nitro upgrade. You don't have to time anything. It'll just sort of work on both stacks. And that's mostly a lot of that's tooling around cross-chain messaging. Yeah, there's a number of other little things that change. I would say, like, in principle anyway, the biggest change has to do with gas accounting. Because we're using a custom virtual machine now, it has its own, it sort of has its own, I guess you could say, its own unit or its own way of gas accounting. The actual values look different than what you're used to. Whereas in Nitro, it'll very much match up with Ethereum itself, which on the smart contract level means if you're expecting certain specific gas values in certain places, those might no longer apply. Or if like your test suite, is expecting a certain amount of gas to be used, that sort of thing, you wanna go back to using the values that you expect on Ethereum. So there's a number of other sort of little things like that. So yeah, if you're a developer, you should follow that. Take a look at that doc.
A couple of things. One is there's a pinned tweet here that is a great analogy by Daniel, which is the AVM EVM sandwich and how the different things go in different places for the architecture. The other thing is it's always good emphasizing now we have safer retriable tickets, which is really cool. If you're doing L1 to L2 transactions, we give you more safety guarantees, and we removed one really annoying edge case, which you could hit, but it was pretty unlikely, but now you just can't hit anymore, which is really nice. And if anyone's curious to find this migration doc that we're talking about that talks about the differences, if you head over to our GitHub, that's github.com/offchainlabs, into the Nitro repo called Nitro, there's a folder called docs, then migration, and in there you find the migration notes, which has a lot of interesting information about the Nitro migration.
Perfect. Thank you. Thank you for sharing. I have one question about Nitro because it's something that I read. Is it going to enable compression initially, or like the call data compression, or is that something that is going to happen after the Nitro migration? Like, not sure if it's paired with the Nitro deployment or is something that comes after that.
I believe we will be supporting compression out of the box. Yeah. So basically, call data will be compressed with I think broadly is the compression algorithm we're using. If not out of the box, then soon later. But I think that is the current plan. Yeah.
Exactly. And
yeah.
Go on. Sorry, didn't mean to interrupt you.
No, go ahead.
So to say something else that's really cool about the compression is we actually charge your transaction based on how compressible the transaction's call data is. So it's not just about like putting in shorter call data and trying to squeeze everything into 32 bytes and all that. It's actually when we're charging the fees for it, we actually check how compressible your serialized transaction is with Broadly and charge based on that. So sometimes it's maybe not about like shortening everything to a byte 32, but maybe using repeated digits, which makes it more compressible and stuff like that. And this is something that we've seen some devs start to look into and explore. And yeah, that's something that we can also dig in and work on to help you guys better leverage.
Yeah, and that's another just new aspect of the Nitro system. There's kind of a new way of handling this this pricing of L1 call data, which, yeah, as Fred said, includes the ability to kind of reasonably estimate or reasonably put a price tag on how much data your transaction will ultimately contribute to. There's inevitably a bit of estimation in here. You can see there's a research forum post we have explaining this, but yeah, that's an example of one of the things that we're kind of like also including within Nitro. And yeah, basically, I mean, the core reason that we can more easily do call data compression with Nitro is the fact that we're just the inputs of the VM are just O code because we're compiling Geth now. So we can sort of use battle-tested Go libraries as part of the VM, and so as part of what is guaranteed by safety. Whereas in the classic system, in the current system, because we have a custom VM, we would have to like have a custom implementation of a compression algorithm, which just introduces some risk there. But now we kind of get it for free. So yeah, that's one of the big vectors for cost saving in Nitro is called data compression. So we're excited.
Great.
If anyone has any other questions, even anyone in the room, I'm happy to open it up.
I think there was one more question actually that
oh yeah,
you had on, like, I guess technically the graph had for us, but for the Arb team, what are some of the coolest features that you have in the contracts or have spotted in Arbitrum while developing, and what are some that may be missing?
Sorry, was this for the Arbitrum team or for us?
For the Arbitrum team, or I guess technically, yeah. I mean, I guess it could apply to both. So if you get some cool stuff too, I'm sure that would be nice to bring up. Cool is very subjective, by the way. So
I can start.
Go first. Yeah.
Go on. Sorry.
No, I was saying I'll let you folks go first, actually.
Yeah. So I'll maybe I'll talk about one feature from our token bridge that I think is cool and one from yours. I think on our token bridge, a feature that isn't actually used, at least I'm not familiar with anyone who's leveraging that, but I think it's pretty cool, is tradable exits, which is pretty much you can start an L2 to L1 transaction and everyone knows it will reach there after 7 days. Just Ethereum itself doesn't know, but it will know 7 days from now. And one thing that we allow you to do is for you to kind of front run this slow message and just say yourself being like, hey, this is going to arrive here 7 days later. And once it does arrive, instead of sending these tokens to me, send it to this other address. And just this very simple primitive, which we call tradable exits, it just allows you to build so many things on top of, which I find particularly cool. You can do fast exits on top of that, just integration for more functionality, many different things. The design space is quite big. And yeah, it's something simple, small, and pretty cool. And something that I think that's really cool that you guys have been working on is the reelers and the keeper stuff for actually maintaining this cross-chain stuff, which I think is pretty cool as well.
Pablo, you want to share maybe one of the cool stuff from our side?
Yeah, I mean, from our side, it's a tough question, so I'll let you think about it while I answer on the ARB side. So at the risk of being redundant, I do think, we talked a lot about retrievable tickets, and I do think those are a very cool feature. It's one of those things that when I started reading about it, it was like, what's this? Why is it so complex, I guess? But then when you start going a bit deeper, you realize, oh, okay, they've really covered all of the bases of all of the things that all of the edge cases and the problems you might hit while trying to send transactions cross-chain. And yeah, in the end, it's really, really powerful. So yeah, I thought that was very cool.
Yeah, and lots of credit to Ed Felton for that one. He's not on this call, but he's the founder and chief scientist who thought a lot of this through very early on. And I felt like I was trying to play catch up. But yeah, it turns out, I mean, I think for these sorts of cross-chain messages, because we're the first, really the first EVM compatible rollup to go live, we sort of hit this the first and had to solve these things. But I imagine, I'm curious if over time retrievable tickets or something like it will become more of a more general standard that other chains use, because it seems like you need something like this if you want to sort of do cross-chain messaging in a reasonable way. So yeah, not that this is specific enough for now to Arbitrum that we haven't thought too much about standardizing it, but that's an interesting thought.
For sure. And we heard from a couple of teams that at first sight, it is a bit daunting that it's just a lot of stuff going on there to be exhaustive and powerful as it is. But we've taken that into consideration. And that's why one of the things that we did is work quite a bit on the SDK. The TypeScript SDK we put out, it abstracts a lot of the interactions and the things you would think about when using retrieval. So you just try to streamline it for developers. The Open Zeppelin team has also been working on just like common set of contracts and libraries that help you leverage and use these features, like cross-chain transactions, less of a headache. And also internally, we've been assessing, right? Is there maybe a way to keep how powerful retrievables are, but also have a more streamlined for devs who don't want to face or don't need to face all the different things that are going under the hood, right?
Yes, this is true. There are alternative models that sort of make different trade-offs, but are a bit simpler in some ways as one of the trade-offs. So yeah.
I do think another thing is you guys abstracted it quite well with the L1 Arbitrum Messenger and L2 Arbitrum Messenger contracts. Like, okay, I have an interface that looks very similar on both sides, and at least when working on the smart contracts, it's pretty straightforward to just call those when you want to send stuff.
Sweet. I think Fred gets the most credit for that. I think. I don't know. It's been a while. But yeah,
it has been a while. Team effort.
Forget exactly who did what. Team effort. But no, yeah, that's cool to hear.
Awesome. I think then, unless anyone has any objections, we can see if the community has any cues they want to ask either the Arbitrum team or the graph. If you do, feel free to raise your hand and we will bring you up. Also, I feel like we started off the space with a little more people speaking. Did one or two people drop off without me knowing?
We lost Chris.
Yeah, maybe they had to leave. I think Simon was here, but he maybe left for a meeting or something.
Okay.
Also, I think this is the first Twitter Spaces in which we're not rugged during it, so it's pretty cool.
Yeah,
the tech held up.
Only Chris got rugged, but it's not really Twitter Space's fault, I don't think. I think it was his phone. So yeah. And yeah, no, it's officially 11, so we can claim a successful Twitter Space. Good work.
Very nice, very nice. Well, I mean, I guess either way, if for the time being, for people who do have any technical questions relating to the protocol, where can they go to get those answered generally? And I guess Daniel, Fred, you can kind of speak from our side on that first, and then I'll throw it over to the graph.
Yeah, well, first off, let me just give a shill for, so this Twitter account that's hosting the space, Arbitrum Devs, is official, and you should follow it if you're interested in like the technical stuff. We're going to share the more technical stuff here moving forward, and the Arbitrum account will be more for general updates, community stuff, and things like that, partnerships, blah, blah, blah. So follow that is one place. You can always go to our Discord, is a good place for questions. Or just like ask stuff on Twitter, I'll probably see it.
Okay, thank you. It was fun.
For sure. Thank you for joining us.
Yeah, and Ariel, just to make sure, if people do have questions about the graph, where can they go on your end to make sure they get those questions answered?
Okay, thank you. Now I need to leave for a meeting, but good to see you all here.
Good seeing
I'll
you.
answer that. I think it's Discord, probably. I'm probably the worst person to answer this, but I would say there's a graph Discord that people will go to.
If they Google the graph, they can probably figure it out,
Yeah, the graph.
Sorry,
the graph
I didn't understand.
Definitely has a lot of resources.
Yeah. Great docs, by the way.
But maybe Pranav is the right person to answer this, but yeah.
Awesome. Yeah, sounds good. Well, yeah, no, we really appreciate you guys for making the time today. Obviously, y'all on the graph side, and of course, the engineers on our side. There are definitely going to be more of these office hours going on in the future. Either with different teams or with just the Arbitrum team alone. If you guys have any questions, obviously feel free to join our Discord and kind of leave them there. But in the meantime, we will see you in the next one.
Bye.
Peace.
Have a good one, y'all.
Thanks for having us. Cheers.
Cheers.
Cheers.